This conference will now be recorded.
Hello everyone. So today we will discuss previous year's questions from the chapter Hydrocarbons, and that will be from the exam IIT JEE Advanced. So here we have the first question. The reaction of 4-methyl octene and this molecule is P, 2.52 gram, that amount is given. Okay. Now it is treated with, that is reaction with HBr in presence of C6H5CO whole to O2. So this molecule is nothing but peroxide like this, PHCO, OO, then again COPH. So this is actually having some peroxide linkage. So this reaction is nothing but addition of HBr to CC double bond in presence of peroxide type of compounds. We know when there is peroxide compound and we are adding HBr, it is anti-Markovnikov addition. So that reaction we have to consider here. It is giving two isomeric bromides in 9:1 ratio. Now 2 bromide, why we are getting? Because two types of reactions possible depending on whether it is Markovnikov or anti-Markovnikov. Though anti-Markovnikov will give us the major product, and that is why it will give this 9:1. That means 9 will come from the major product and 1 will come from the minor product. Major product means which is according to anti-Markovnikov. Now it is mentioned with combined yield of 50%. Combined yield, that means you have started from P. You know what is the mass of P, which is 2.52. Now once you draw the molecule of 4-methyl octene, from this molecule you can understand what is the chemical formula. Once you know the chemical formula, you know the molar mass, and once you know the molar mass, you know how many number of moles of P is present. So if it is X mole, overall yield 50% means what? It will be only X by 2 moles will be taking part in reaction. Now out of this X by 2 mole, 9:1 ratio you have to consider. So first you will find the number of moles. Next you have to find the 50% of these moles. Then out of that 50%, 9/10 amount is the amount of the actual major product. Okay. Now go to the next statement. Of this, the entire amount of the primary alkyl bromide. Primary alkyl bromide is actually the major compound. Remember, bromine is added to the terminal position, which carbon is containing higher number of hydrogen. So this will be the primary alkyl bromide. It is again reacted with an appropriate amount of diethylamine. So diethylamine is 2-ethyl substituted ammonia. So it is Et2NH. Followed by treatment with equivalent amount of K2CO3. This is base. To give non-ionic product is 100% yield. You have to find the mass of S in milligram. This is very important. Don't overlook it. In the bracket, it is mentioned in milligram. So if you are somehow doing the calculation in terms of gram, it will be wrong. So be very careful. It is in terms of milligram. Now we will write all the structures here one by one. So whenever you are getting this type of compounds, the first thing you have to do in the rough work, whatever informations are there, write every information on the rough paper so that all the informations are in front of you, and do it clearly, neat and clean, so that you are leaving the question, you are coming back, you can again start the question. Okay. So P, first we will draw the structure, 4-methyl octene. Now oct means what? 1, 2, 3, 4, 5, 6, 7, 8. Total 8 carbons will be there. Terminal position there is in, and at 4 position there will be a methyl group. Now when you are treating it with HBr in presence of some peroxide compound, I'm simply writing par, which means peroxide compound, it will give us 2 isomeric product. So the major product will be this one, where bromine will be at the terminal position. 1, 2, 3, 4, 5, 6, 7, 8. And at 4 position there is methyl group. So this is the major product, but we will also draw the minor product. Minor product, bromine will be added here. So this is the 4th position, methyl group is here. So this molecule is P, right? Now 2.52 gram, you have to write its corresponding, that is how many carbons are there, how many hydrogens are there. So total carbon is 8 carbon parent chain and 1 methane. So it is C8. And look at the hydrogen number. It is 18. So it is it is 9. It is 18. So if it is C9H18, the corresponding molecular weight, if you calculate, you will see it will be 126. So this is the molecular weight of this compound. Now 2.52, if you divide it by 126, total number of moles you will get, which is 0.02. Now overall yield is 50%. That means overall yield, that will be half of it. So 0.02 mole, this is 9. So if it is half of it, 0.01. Now 0.01, if you take 9 by 10 amount of this amount, that is 0.9, then you will see it will be 0.009 moles. So you understood what I have done? First, you find the number of moles of C9H8, which is our P. So this is P. For P, molecular weight is 126, that you can calculate from the formula C9H18. Then this is the number of moles of P. 50% yield, that is why now I have written 0.01. And out of this, 9 for the measure, this is measure according to anti-Markovnikov, and it will be first 0.01 divided by 10, 0.001 multiplied by 9, so it is 009. Simple calculation. Now if it is 0.009, next reaction is of the entire amount of primary alkyl bromide. Now this major one is actually primary alkyl bromide. This is not primary alkyl bromide, so we will not consider it. It is treated with appropriate amount of diethylamine, that is ET2NH. So when you are treating it with ET2NH, the product that you get, 2 ethyl groups. So it will basically attack this carbon, bromine will be removed. 1, 2, 3, 4, 5, 6, 7, 8. 4 position, there is methyl group. So this is our compound, and here as NH is attacking, hydrogen is still there, it will be carrying some positive charge, and Br minus is the counter ion. Next, you are treating it with equivalent amount of K2CO3, that means 1:1. So this is base. What it will do, it is basic in nature, so it will capture HBr. So it will basically remove this H plus and Br minus. Overall net removal of HBr. So when it is removed, finally you are getting the compound 1, 2, 3, 4, 5, 6, 7, 8. Just check whether all the carbon numbers are fine or not. So this is our final product, right? Now here it is mentioned that with 100% yield, if this is S and if this is 100% yield, now you have to write the corresponding molecular formula. So it has molecular formula. Carbon number is again now 4 carbon extra from the methyl group. So 4 plus 9, it will be 13. So I am just writing so that just to save time, you have to do it carefully. So this is the molecular formula, okay? And if you calculate the molecular weight from this formula, you will see it will be 199 gram per mole. Now this is gram per mole, molar mass, and here as it is 100% yield. So if this compound is 009, this S will also be produced 009 moles. So simply multiply with it 199, which is gram per mole. So the answer that you will get, it will be in terms of gram. It is not in terms of milligram. Be very careful. It is asking in terms of milligram. So you have to finally multiply it with 1000. So our answer should be 1791 milligram. This is the final answer. Okay, 1791 milligram. Fine. So we'll move to the next question. This is an integer type of question. So here all the atomic masses are given, so it will not be a problem. Though it is true that bromine is not required. Sometimes some extra informations are given, so don't think that you have to always utilize all the information. It is just there maybe to confuse you. So we just need hydrogen, carbon, and nitrogen, these atomic weights. Though these are very easy, we always know what are the values. Next question is, if the reaction sequence given below is carried out with 15 moles of acetylene. So the starting substrate is acetylene. You have taken 15 moles of it. Iron tube red hot. Now if you consider this reaction, iron tube red hot, you are getting A. Simply forget about what yield is mentioned. If it is theoretical yield, how many you should get? We know from 3 molecules of acetylene, that is if you take 3 molecules of acetylene, you get 1 mole of benzene. That means it is 3:1. 3:1 means if it is 15 moles, you will get 1/3 less. So it will be 5 moles. Okay. So you have started with 15 moles of acetylene and you have to find the product D formed. That is the final product. There are many steps in terms of gram. Atomic masses are given. Now if it is benzene 5 moles produced, but yield mentioned 80%. So 80% of 5 you have to calculate. Okay. And you will see it will be 4 mole. Now if it is 4 mole, next reaction is CH3, CH2, CH2, Cl in presence of Lewis acid AlCl3. Now this is Friedel-Crafts alkylation. In presence of Lewis acid, there will be first generation of this CCl bond will be removed and there will be AlCl4 minus. But what is the fate of this carbon chain? There will be formation of positive charge like this. But this is 1 degree carbocation. So there will be rearrangement. So this hydrogen will be shifting here and you will get positive charge here. This is 2 degree, this is 1 degree. So this type of rearrangement will take place. So the product B that you will get, it will be like this isopropyl group. It is not straight chain N-propyl group, it is isopropyl group. This is molecule A, this is molecule B. Now B is 50%. That means you have started from 4 moles of benzene. Now there will be 2 moles of this substituted benzene. Next reaction is oxygen in presence of H3O plus minus CH3COCH3. Now this reaction is basically, I am just showing you this reaction. This molecule is known as cumene, which in our case is B. When you treat it with oxygen and finally water medium acidic condition, first this oxygen 2 atoms are inserted between carbon and hydrogen like this. That is this CH bond, it will be inserted between this carbon and hydrogen. 2 oxygen atoms will be inserted and peroxide type of linkage will be there. Finally, there will be rearrangement and see as if this portion is removed and only OH is there. So that is why it is mentioned here as if one acetone fragment is removed. So your product is phenol. So C must be phenol. C is phenol. Now from B to C again 50%. That means this should be 1 mole. Fine. Finally, you are treating it with CH3COCl in presence of pyridine. So it will be, that is this oxygen OH group, it will attack CH3COCl. So it will attack here. Cl will be removed and the product that we will get, it will be OCOCH3. Okay, this is our D and it is mentioned 100% yield. That means this should also be 1 mole. Okay. Now why pyridine is given? Because see here net removal of H and Cl taking place. That means pyridine is basic in nature, so it will capture this byproduct which is HCl. So whenever there is some reagent given and if you are having any trouble to understand what is the role of this reagent, just try to understand whether the reagent is basic or acidic, because sometimes if it is basic reagent, that means the byproduct that we want to remove so that the equilibrium is shifted towards right hand side, that byproduct may be acidic in nature, or it may be vice versa. That is, if the reagent is acidic in nature, then your product, unwanted product or fragment that you want to remove, that should be basic. So this is 1 mole. Now here we will calculate the formula, because you have to find the amount of product in terms of gram. Benzene ring 6 carbon, 2 more carbon, so it is C8. Total number of hydrogen, 5 hydrogen in benzene ring, 3 hydrogen here. 5, 3. Okay, it is 8. And we have 2 oxygen atoms. So you will see C8 means 96, 8 into 12, then 8, and then 32. So total mass you will see, it will be 136 gram. And that is actually your answer, because the number of moles is simply 1 mole. So answer should be 136 gram. It is asking in terms of gram. So this is the answer, 136. Number of isomeric tetraene. Tetraene means what? Total 4 CC double bonds will be there. That is why it is tetraene. In the bracket, it is mentioned not containing sp hybridized carbon atom. Now, what is the meaning of it? Suppose you have CC double bond like this. CH, CH. Okay. But you can, and in this case, it is sp2, right? Because both sides, that is here, you have some sp3. So this is sp2. But another possibility is also there. Suppose if I am writing CH double bond C, then another CC double bond. Now, further substitution may be there, this side or this side. Now, in this case, it is sp2, but the middle carbon, both side, because of this both side double bond, there is basically 2 pi bonds. So it will be sp hybridized. So you should not consider this type of double bond, because total 4 double bonds you have to find. But if you are thinking that this type of double bonds are there, that also you should count. No, that you will not do, because it is mentioned in the bracket not containing sp hybridized carbon. So there should not be any sp hybridized carbon. So this we have to take care of. Now look at the molecule. What is given? In the molecule given, there is CC double bond and there is CC triple bond. And the reagent is such, that is the first reagent, sodium in liquid ammonia. Now sodium in liquid ammonia, it only reacts with triple bond, and there will be trans addition of hydrogen, because the reagent is such. Now if it is trans addition, hydrogen, and then methyl group, right? Next, what we are doing, the next reagent is, this is number 1 reagent, this is number 2 reagent. You are adding bromine excess, because total number of CC double bonds 2. Now, ignoring the stereochemistry, that is not required here, I will write 2 bromine. One, two, three, 4. So don't forget the methyl group. Okay. So whatever is stereochemistry, that is not important. Next, we are adding alcoholic KOH. Now, alcoholic KOH, when we add, when we want to remove HBr fragment, fine. Now, there is total 4 Br atom. That must be total 4 times HBr removal will be there. Now, beta hydrogen you have to consider. Now, if this is alpha position with respect to Br, this hydrogen you will remove. So, these two you will remove together. Now, if you are thinking that I will remove this H with this Br and this hydrogen with this, then what will happen? You will get something like this. Though in the ring structure, this type of CC double bond side by side, it is not possible at all, because of this arrangement of ring structure. It is not possible, because in the this carbon is sp and it must be linear. So it is not possible here. So this beta hydrogen, these two you will remove together, and this Br, that you will remove together. Okay, these two. Now come to this side, HBr. This is beta position with respect to this. So remove these two together. And here also you have alpha and beta hydrogen. So when you are removing it, what you are getting? You are getting double bond, double bond, double bond. Now total that is 4. This is tetraene molecule, but it is asking number of isomeric tetraene. Now try to think, is there any isomer possible for this double bond? Because you can consider cis-trans type of geometry. Now for the ring structure, the two double bonds that you have, cis-trans you cannot do anything because these are fixed, rigid. And also for this terminal CC double bond, you cannot do anything because here cis-trans question does not arise. But if you focus on this CC double bond, here the position is configuration, isn't it? Because this side you have a large group, the two hydrogens are like this. So another structure is also possible, and that structure I will write with a plus sign. So this part is again fine. Now this can be Z orientation. So when it is Z orientation, these two hydrogens are on the same side. So it will be either E or Z. That means total 2 types of isomeric tetraene you can get. So our answer should be 2. Fine. Number of methylene group. Methylene group means CH2 and both sides there may be any substituent. Don't think it is methyl. Look at the spelling. It is methylene, CH2, not CH3. Number of CH3 groups in the product formed from the following reaction. So following reaction sequence, because it is not a single reaction, there are so many steps that you have to consider. Now the starting material, there is CC double bond, and this side you have 3 carbon, this side also you have 3 carbon. So this is symmetrical, trans but symmetrical. The first reagent is you are doing ozonolysis. Both the steps together, that is first you add ozone, you get ozonide, then you do reductive cleavage. Now both sides we will get aldehyde. 2 molecules of aldehyde basically you will get, right? Next we are adding KMnO4, which is reagent number 2. Now it is oxidizing agent. So this will be now converted to carboxylic acid. The next reagent is number 3, where it is NaOH electrolysis. Now we know coal-based electrolysis, when we do this, 2 molecules, already 2 molecules are there because after ozonolysis you get 2 molecules of aldehyde, then 2 molecules of carboxylic acid, and now you are doing NaOH electrolysis where 2 molecules are actually needed. Now here you have total, this part will be removed in the form of CO2, and in this part you have total 3 carbon. So 3 carbon 2 times, that means you will get 1, 2, 3, 4, 5, 6, total 6 carbon. So this will be the product after 3. Finally, if you treat it with reagent 4, Cr2O3 77 Kelvin, 770 Kelvin, which is very high temperature. Look at that pressure, this is also very high. And this reaction is actually benzene formation. So total 6 carbon, so it will form a ring type of structure, and final product is benzene. So total 4 steps we have done here. First ozonolysis, then oxidation. Our CHO group is oxidized to CO2H. Then NaOH electrolysis, coal-based electrolysis, where CO2H fragment is removed in the form of CO2. 2 times CO2 will be removed. And 3 carbon together it will combine. It will form 6 carbon alkane. This is actually alkane formation technique. And then benzene preparation technique, which is in presence of the reagent Cr2O3, high temperature, high pressure, you are getting benzene. Now come to the actual question. The number of CH2 groups. Is there any CH2 group? There is no CH2 group. So the answer is 0. Okay. Now this question, we have to write many steps. Here P, that is your starting point, because look at the reagent arrow direction. Left hand side the arrow is going towards optically active R. Right hand side arrow going towards optically active acid, which is Q. Formula is also given. Now R you are getting when you are treating P first with sodium amide, then PHCOCH3 acetophenone, and the third reagent is acidic aqueous medium with heat. And in the right hand side, you are treating P first with reagent X, and second reagent is KMnO4 acidic condition, KMnO4 heat. There is another arrow also downward, PTH2. It is simply hydrogenation in presence of metal catalyst, platinum. Now look at the options. You have to choose correct option or options. More than one answer may be correct. Now A and C is related to structure of P. Structure of P for A and C option, both are actually same. Only difference is here these two are 1-3 position, but here it is 1-2 position. That is the only difference. Option B is related to the reagent X, and option D is related to the structure of R, that is the left hand side optically active R. And X is reagent PDC. This is actually linear catalyst where C's addition, C addition will take place. Now, when you are getting this answer, how you will start? You should start as P structure is given, and you know when you do simple hydrogenation, PTH2, you are getting this type of product. Now, this type of product you can get from option A. You can also get it from option C. So both probabilities are there. So just try, just choose any of option A or C, because directly just by imagining you cannot do so. Just choose any one, either option A or C. And once you start writing all the products one by one, eventually you will understand that whether P is option A structure correct or P option C structure is correct. So let me choose from option C P structure, which is like this. Now when you are treating it with sodium amide, first you will get, there will be trans addition. So it will be H. Basically here cis trans doesn't matter because after, sorry, it is not hydrogenation, very sorry. It is basically acting as base, and it is terminal, having terminal hydrogen. So there will be negative charge generation and Na plus. Now the next reagent is PHCOCH3. So this negative charge over carbon, it can attack here, and you will get OH, CH3, PH, right? And here you already have this, sorry, one carbon I have missed here. It will be like this. Now, the next reagent is H2O plus heat. That means here OH will be removed, dehydration will be occurring. So CC double bond will be generated with pH. Now this structure, it is saying that it is optically active. Now is this optically active? Yes, it is optically active, because if you consider this part, it is actually chiral center. So this is actually, we are getting correct result, optically active. Now what we'll do, we'll do the other part. Now in the other part, it is mentioned as X reagent. Now just consider that it is the reagent. We will check whether it is, we are getting same correct result or not. So this is linear catalyst, and CC triple bond, that will be now converted to CC double bond. Now once it is converted to double bond, next you are treating in acidic condition, then KMnO4, you are also heating it. So when it is this type of reaction, it is not simple dihydroxylation, that is basically cold dilute KMnO4. Now it is hot KMnO4 acidic condition. So that is why it will be this CC bond cleavage will take place, and you will get CO2H here. But this part will also not remain intact. It will also be cleaved, because it is a strong, it is very harsh condition. H plus KMnO4, you are hitting it. CC double bonds, all the CC double bonds will be cleaved. So if you are breaking it, you will get CO2H here and also CO2H here, right? Now look at this. Is it C8H12O6? Total number of carbon? Yes, it is C8. Then count the hydrogens. It is 12. Total oxygen, 3 CO2H group. it is 6. So it is matching. Is it optically active? Yes, this is also optically active. This center is a chiral center because with this chiral center, all the 4 groups are defined. That means the structure that we have chosen option C, that is actually we are getting correct result. But structure of R is not matching because this R is not this one. So option D is not correct. Option C is correct. Option B is also correct. Now, if these two are correct, and just we'll check for extra information, what is the problem if you have started with the other structure, which is this one. Now, if you have started with this, you will see the structure of R that you will get from this. I'm just jumping all the steps. It will be now matching with option D, but that actually we are it is matching with option D, that is fine. But just check, is it optically active? Yes, this is also optically active. If you start from option A, structure of P, you are getting this side correct result. Option D seems correct. But what about Q? If you now do the same reaction for the right hand side reagent, first you are treating with X, then you are doing oxidation with KMnO4, you will see the CO2H structure, that is the triple CO2H structure that you will get. It will be something like this. CO2H, CO2H, and then CO2H. Now this center is not chiral because these two groups are same. So that is why, though this side we are getting fine, results are okay, but this side we are not getting optically active acid. That is the reason this option is not correct, and also this one not correct. Only B and C correct. Which of the following reaction produces propane as a major product? So propane as a major product, that means for each reaction you should get CH3, CH2, CH3. Or produces, that means one option may be correct, or it may be more than one options are correct. Now it has to be the major product. Now the first reaction is, you have taken sodium salt of butanoic acid. Total 4 carbons are there, 1, 2, 3, 4. Now when you are doing electrolysis, sodium will be removed and CO2 group, that is a carboxylic acid group, that will be removed in the form of carbon dioxide. But in electrolysis, what happens? Just remember in the previous one problem we have just seen. So this part will be removed as carbon dioxide, but from this side there is three carbon fragment. Now 3 carbon fragment will be connected together. You will be getting some 6 carbon fragment, but this is not correct. That is, it is not propane. Our aim is to find those options where you will be getting propane only. But this is hexane. It is not correct. Then option 2, NaOH in presence of calcium oxide heat. Now this is soda lime reagent, and the purpose of using soda lime reagent is that it helps in decarboxylation. So in this case, basically you will get propane because here simply CO2 is removed and soda lime helps in decarboxylation, decarboxylating agent basically. Then the third reaction is, you have chloropropane, 3 carbon, then chlorine. Now when you treat it with Zn and dilute HCl, Cl will be replaced by H. First what happens, Zn is inserted between this carbon and halogen, and then it is removed, and in that place of ZnCl, hydrogen will come. So this will also give you correct result. What about the next one? When you treat it any 1,2-dihalo compound with Zn, Zn combines with this and it forms ZnBr2. So you should get CC double bond. That means this is not giving you propane as the major product. So this is the final result. The first one basically you will get N-hexane. The second one you will get propane. So this is okay. We will choose it. Third reaction is, first between this CCl there is Zn insertion. Then dilute HCl, this part will be replaced by H. So this is also correct. But in the last one, this is basically unsaturation is generated in the molecule, because here ZnBr2 is removed. So correct answer should be option 2 and option 3. Only these two options are giving you propane. Okay. Total number of hydroxyl groups present in a molecule of the major product P is. Total number of hydroxyl groups present in a molecule of the major product. So P is our major product. Okay. Two different reagents are given. First reagent is H2 PDBaSO4 and then there is quinolane. And the second reagent is dilute KMnO4 excess. Now when you are using potassium permanganate dilute condition, even if alkaline or acidic not mentioned, and look at the temperature also, it is 0 degree. That means it is not harsh condition. So when we have this type of mild condition and you have any CC double bond, what happens? Simply dihydroxylation takes place by the cleavage of pi bonds only, sigma bond is still there. But in the one of the previous question we have seen, when you treat it with a strong KMnO4, that is concentrated acidic condition, you are providing heat, then what happens? This sigma bond is also broken, but that will not be happening here. So after the treatment of the first reagent, CH2 double bond, then another CH2. Be very careful about the number of carbon atoms. This is 6 membered, this is 5 membered, this is 6 membered, and position of double bond is here. Now when we are treating it with KMnO4, so all the double bonds, now you have to write which you don't have to think about the stereochemistry, that is not required here. So here total 1, 2, 3, 4, 5, 6. So total 6, total number of hydroxyl group present in the final product P. The answer should be integer type of question. It should be 6. Okay. The reaction leading to the formation of 1,3,5-trimethylbenzene is or are. One option may be correct. More than one option may also be correct. So this is benzene. 1 position methyl group, 3 position methyl group, 5 position methyl group. So this should be your product. So only those reactions you have to choose where you are getting this product. Otherwise that will not be your correct answer. Now the first option is given acetone in presence of concentrated H2SO4 and heat. Now 3 molecules of acetone if you take in presence of concentrated H2SO4, there is actually formation of 1,3,5 substitute methyl substituted benzene. Look at the carbon number. 3 molecules of acetone if you take, in one molecule you have 3 carbon, that means total 9 carbon should be present in the final product, and that is we are getting also 3 methyl and benzene ring 6 carbon, 3 methyl, 3 more carbons are there. So this is 1,3,5-trimethyl benzene that we will get from the first option. In case if you are curious to know how we are getting this type of product, though detailed mechanism not required, but still for if you are curious to know it, it happens in this way. First, one acetone molecule is just like this. Another acetone, it is in enol form. Now the enol form, when this OH bond is broken, there will be OC bond, and this CC double bond will be acting as if it is a nucleophile, and this C double bond O as if this is the electrophile. In the medium, you already have H plus, so you will be getting this type of structure, number 2. Now there will be CC bond generation at this position, and this oxygen will take H. In the next step, this OH bond is again broken, CC double bond is shifted here, and OH is removed. So water, as if net removal of water molecule. Then this methyl group, one of the hydrogen, it is CH bond is broken, and that is why we are getting CC double bond here. Then this CC double bond is shifted, and from C double bond O we are getting OH. Another molecule of acetone, So basically see, already we have obtained 4B, which is already there is 4 carbon. Now 2 more carbon we have to attach more. So the applying the same type of mechanism. See, here multiple arrows are given. That means you just have to follow the previous mechanism. So this is the newly generated bond in red color, and then it is in 5A. You can draw it in the enol form. So when it is in the enol form, as if one of the hydrogen, it is making a CC double bond. This is only shifted. This is shifted, and as if it is taking another H plus. Now you are getting 5B prime. This 5B prime. Now CC, this part is again in the keto form, from enol to keto form, so that this CC double bond can act as nucleophile and it can attack this C double bond. Finally, we are getting this CC bond, and gradually you will be having this type of benzene structure. 5B prime can also be written like this. That is another way, pathway may be also there, but final product is 135 trimethyl benzene. So in this way, from 3 moles of benzene acetone, you get 1 mole of 135 trimethyl benzene. So this should be our correct answer. Next is methyl, then CC double bond. Now we know when you take 3 acetylene, you get benzene. Now you have taken methyl substituted acetylene and you are treating it with heated iron tube. So obviously there will be methyl substituted benzene ring, right? As if it is like this. So if you follow this type of arrow as I'm moving, you will get ultimately 135 tri-substituted benzene. Same mechanism as we do with the 3 molecules of acetylene. Here extra methyl groups are there. That is the only difference. And it will not make any change. It will be same. So this should also be our correct answer. What is the happening in case of option C? We are treating it with bromine NaOH. Now when it is a reagent that we use in iodoform or bromoform reaction, it will be either bromine NaOH or iodine NaOH. So when you have some COCH3 fragment, that part is converted to CO2 minus Na plus. But as you are treating it with H3O plus also, then it will be converted to CO2H. But you are also treating it with soda lime in the third reagent. As a result, all the CO2 groups, 3 times CO2 groups will be removed. And ultimately the product will be simple benzene. It is not methyl substituted benzene because this part is already removed. This carbon will be removed in the form of bromoform. Now, and the carbonyl will be converted to CO2H first. And that is a bromoform reaction, or in general haloform. And finally, as soda lime is there, this decarboxylation will be taking place. You will be getting benzene. So this is not correct answer we are getting. And here we have Clemenson reaction. So in Clemenson reaction, C double bond group is converted to CH2 group. Okay, that means here also we will be getting, if this C double bond H, if this part is converted to CH2, C double bond to CH2, what you get? You get methyl group, right? I'm just showing it with one. CH2 group is converted to CH2. So it is ultimately CH3. So all the 3 options A, B, C, D, except C, because in case of C, you are not getting substituted benzene. This should be the correct answer. Okay. So that's all in this video. We have discussed 6 to 7 questions. I hope it will help you. Thank you for listening. We are ending the session.